first design. Already, it was showing promise. Our talented team came up with a design that already the ratios were down to about 0.4, 0.39. And the highest forces that were acting on any part of the bridge, about 800 newtons. That is an extremely good start. We knew that this would be a great design to moving forward. However, as it was so openly pointed out by Mr. Boyarsky in class, our bridge had too many pieces. We wouldn't be able to build it with the amount of materials we had. So, we quickly researched and revised the design of our bridge to be much simpler. If you look here, we can see our design that eventually came to be our final bridge design that we ended up building. As you can see, it's much simpler, but the forces were about the same on it. Nothing had been sacrificed but a few extra pieces. Still, we had the arch design, although it had been moved up. Now, this bridge had slightly higher forces acting on it, but we were willing to bet that with some good building, it would do extremely well in the testing phase.
Alright, so for our construction plan, on day 1 we had to build both sides. Day 2 we put the two sides together, and day 3 we expected there to be some issues, so we would fix those up. And then what actually ended up happening is day 1 we did get both sides done, but day 2 we were not ready to put the two sides together and spent the whole class period trying to come up with it. So overnight we built a little scaffolding thing to hold the parts together.
The final force that held the bridge was 7.4 newtons. The bridge broke directly in the middle. There was a center beam that was going straight to the bottom. Most of the force was being exerted through the beam. If we would have had more beams to dispense the pressure, it would have been able to withhold more force.